x squared minus px plus 1 is a factor of ax cubed plus bx plus c, where a is not equal to 0. Show that c squared is equal to a times a minus b. So we set up our bus stop and we put ax cubed plus bx plus c underneath the bus stop. Notice that we have a gap here. That's because we don't have an x squared term. And then we put x squared minus px plus 1 outside the bus stop. So this is our highest common factor, so we're going to divide this into the bus stop. So we take the highest power of x inside the bus stop, ax cubed. We're going to divide it by the highest power of x outside the bus stop, x squared. Ax cubed divided by x squared is ax. So this goes on top of the bus stop. Then we take the ax and we multiply it by the x squared minus px plus 1, which is the highest common factor. So ax times x squared is ax cubed. Ax times minus px is minus apx squared. And ax times 1 is ax. This goes underneath the bus stop. Then we change the signs. So this becomes a minus, this becomes a plus, this becomes a minus. We change the signs so that we can cancel out the ax cubes. Then we simplify. So we have plus apx squared. We have nothing to add there, so we just bring it down. Apx squared. And then bx minus ax, we factorize out the x, and we're left with b minus a. And then we bring down the plus c. Then we repeat the process. So we have to have a look back at the question again and the phrasing of the question. We are told x squared minus px plus 1 is a factor of ax cubed plus bx plus c. So that means we're going to have a remainder of 0, because that means this divides into this evenly with no remainders. So we have to end up with a remainder of 0. So in order to have a remainder of 0, if this is c, then this must end up being minus c. So technically you could say it's plus c, but then we change the signs just like we always do. So in order for these to cancel, and we want these to cancel, these are just the constants at the end, we need to have c minus c, because c minus c is equal to 0. These will cancel out. So we go back to our highest common factor, so x squared minus px plus 1. So what must we multiply this by so that this 1 becomes a c? Well, we just multiply it by c. So we say c times x squared is cx squared. C times minus px is minus cpx. And c times 1 is going to be just c. So that's how we end up getting c up here. Because we want these to cancel out. We want it to be c take away c, which will give us 0. So to make that 1 become c, we must multiply it by c. So we had to multiply everything else by c. So we end up with cx squared minus cpx plus c. Now we can change the signs. This becomes a minus, this becomes a plus, this becomes a minus, and now these are going to cancel. So they've cancelled out, and next we're going to put like to like. So we're going to do our identically equal polynomials. So the x squareds will just cancel, and we have ap minus c is equal to 0. So ap minus c is equal to 0. Now notice that there's no p in our answer, so we want to get the p on its own. So we have ap is equal to positive c, so p is equal to c over a. So now we have the p on its own. That's what we want because there's no p in our answer. So we wanted to isolate the p so that we can sub it into another equation and then get rid of it. So then we take everything that's stuck onto the x's. So we forget about the x's. We're not interested in the x's. So we have b minus a plus cp is equal to 0. So b minus a plus cp is equal to 0. So b minus a plus cp is equal to 0. So we're going to bring the cp over the equal sign, so it becomes b minus a equals minus cp. Then we swap that p for a set of brackets and we put c over a inside because we got p to be equal to c over a. We bring down the b and the minus a and the equals. And then minus c times c is minus c squared, and that's all over a. And then we just have to get the c squared on its own because we want to say that c squared is equal to a times a minus b. So we first of all want to change this. We don't want minus c squared over a, we want c squared because ultimately we have c squared here. So we multiply across by minus. So that minus a becomes positive a, that b becomes minus b, and minus c squared over a becomes c squared over a. So we multiplied across by minus 1. And now we just have to multiply across by a so that we get c squared on its own. So we get a times a minus b is equal to c squared, which is what we wanted.